All right, greetings, mortals and human beings. My name is Emmanuel from Industrial and Production Engineering, FUTA, or you can call me the Apex. And this evening, in our time currently, this evening, we'll be looking at cost estimation. Cost estimation. Another cost estimation, we have three different methods or three different technique of estimating cost. We have the high-low method, high-low method, or you can call it the range method or range. You can call it the range method in case you know the examiners choose to be a little bit more creative. Then we have the least square method, which is actually one of my favorite method because it's very straightforward, and that's one of the advantage of it. Very straightforward, although the range method is more simpler, but this is very much straightforward. And then the last, we have the scatter graph method. The scatter graph method permits me to bend the scatter graph method. All right, so what is cost estimation all about? Cost estimation really is the measurement of a history of data. Of course, this data is as regards cost. It's a measurement of the history of data to help predict future costs. And of course, all what we have been saying so far is something that is more inclined to the management aspect. So we want the management to be able to make better decisions. So they use the cost estimation method. It's the measurement of the history of your cost data, of past data, measurement of history, of historic data to help predict the future. Because of course, there's a saying that if you don't know the past, you repeat the same mistake. All right, so we now have three techniques. Let's start with the high-low method or the range method. Now, the high-low method is basically the segregation or the breakdown of your mixed cost into your variable cost and your fixed cost. Is the segregation, let me write it here, segregation of mixed cost into the fixed cost and your variable cost. So what are fixed costs? What are variable costs? These are they are a type of cost attributes where fixed costs, as the name suggests, they are constant, they are fixed, no matter the level of activity that the manufacturing company engaged in, whether the output is high or is low, it is fixed. Things like the rentage. So whether the company is producing 30 gallons of paint per day or 50 or 100, or they don't even produce, maybe one of the sections got burnt, they will still pay the rent. All right, but variable costs are costs that fluctuate. All right, they have a direct relationship with the level of output. They fluctuate. So if your output is high, they are high. If your output is low, they are low. Why mixed costs? What we are segregating, mixed cost is it's a very interesting concept. Mixed cost is the combination of variable cost and fixed cost. Now let's say we have a graph. We have this graph, all right? Now fixed cost will go this way. Variable cost, let me call this fixed cost, FC, football club. Then we have variable cost. Variable cost can go this way, all right? It can also go, let me use this dotted line. It can be curved in a concave, or it can be curved in a convex form. All right, now mixed cost is the combination of these two. How does that happen? It can be the cost that is associated with a cost object, such that maybe at an initial stage it is fixed, then with more use it begins to fluctuate, or at the initial stage it fluctuates rather, then with more use it becomes fixed, or with less use rather it becomes fixed. Either way, that is what we mean by mixed cost. So you can draw the graph this way. It was fixed initially, then started varying. That's, you can, if it's a linear if it's a linear variable graph we are talking about, or it can be variable initially, then become fixed. A good example would be you know, your acceleration. As you're accelerating, you get to a particular point, and then it becomes normal. Let's say I'm just using the physics example, like the taking off of an aeroplane. You know, it accelerates, then it gets to the cruise mode. All right. So that's the concept behind the mixed cost and ultimately behind the high-low method. So let's take an example. Our example is from the IPE handout, cost analysis. Example is from cost analysis, illustration 2. Illustration 2. Nice. All right. So here we have student population. Don't worry, as we go on, I would explain some things. All right, so we have the student population. Remember, as an example from our handout illustration 2, we have the student population, we have the total overhead. Overhead costs are all indirect expense of running a business. They are the indirect expense of running a business, but they cannot be tied to, or they cannot be economically traced to the products that the business is, or the services that the business is giving out. All right, let's say paying security personnel, let's say paying your rent, let's say paying buying fuel. Thank you, my boss. So that's what overhead cost is all about. We have the direct cost, we have the indirect cost, we have fixed cost, we have variable cost, we have overhead cost. All right. This overhead is actually a cumulation of your variable cost, your mixed cost, and your fixed cost. So they are the indirect expense of running a business. The indirect expense of running a business. All right. The direct expense of running a business could be your procurement, what you use, the money used to procure your materials. Let's say you are producing cocoa. So what you use to procure the cocoa from the farmers, if you are going to be using alkali salt and all of that lot. So for the student population, all this information are in the illustration too. For the student population, we have the high for both and we have the low. All right. So for the high, we have our student population to be 40,000 and the low to be 30,000. Then for the total overhead, we have the 141,000, and then for this guy, we have 122,000. Now, actually, when solving for the high-low method, we actually have some procedures of which I may not be able to list out because they're already in the handout. But as we go more into the solution, I'll be saying them. All right, so we have this information. Now they told us that for this low student population, for 30,000, all right, for 30,000, they gave us, this is the total overhead cost. And I said the total overhead cost is the combination of your fixed cost, your variable cost, and your mixed cost. So now for the total overhead cost for the low student, that's 30,000 naira. They gave us the breakdown, the literal breakdown. Okay, our direct materials, that's the variable cost, V, they put it at 45,000. Our fixed cost, F, they put it at what? 50,000. And our maintenance cost or mixed cost, they put it at 27 interesting thousand, wherein the summation is 122,000. Now, what is the question? Because it is very, very wearisome to have a long introduction to a question and then the question in itself is hidden. So what is the question? The first question is, this 141,000 overhead for the high students, we're told, number one, we're told to bring out the maintenance cost. That's the maintenance cost from 141,000. So let's start. So let's bring out the maintenance cost from the total overhead of the high students, 141,000. Now we know that this is the formula. Total overhead is equal to total variable cost plus total fixed cost plus total mixed cost or maintenance cost. But in the course of the video, my maintenance cost is synonymous to my mixed cost, because inside the maintenance cost, we still have a fixed cost and a variable cost. All right, all right. So our total fixed cost, from the information we have from the low students, and mind you, the low students actually represent the level of activity. All right, remember we said we made a relationship between variable cost and level of activity. So the 30,000 students that you are seeing there, they are not just student population as it were, but is a representation of a level of activity, level of output. You understand what you are doing. So from the information we have there, because a fixed cost is a fixed cost, whether you are dealing with 30,000 students or 40,000 students, you are still going to pay the same 50,000 naira for the rentage. So because of that truth, as it were, our fixed cost 50,000 naira is still going to be 50,000 naira here. Total overhead, they said we should be working with 141,000. Now, if we are looking for our maintenance costs, let's call this one X as usual. I don't know what happened to this guy. They're always using it. Then let's variable cost. Now we'll have to solve this one. Let me draw an arrow here. Our total variable cost is going to be equal to it's going to be equal to, sorry, skipping my head, number of outputs, which in our case now is the number of students. Number of students times variable cost per unit. Variable cost per unit. No, this does not sound correct. It's correct though. Times variable cost per unit. Cost per unit. Okay. Now, we are working with 4,000 students. Remember, we are working with what? 141,000. So we are working with the high side. And then the student population for the high side is 4,000. So we have the total number of students, but we do not have the total variable, or we do not have the variable cost per unit. Hence, we cannot find the total variable cost. So what we need to do is, we will need to go and obtain the variable cost per unit, which is the same in both the high side and the low side. So yes, we will still come and use this one, the variable cost for the low side. We'll obtain the variable cost per unit, which is fixed for both the high and the low. Then we'll return it back here. So variable cost per unit will be 45,000 divided by what? Divided by number of students, 30,000, which will be equal to 45,123 divided by, that should be giving us 1.5 units, 1.5 per unit. Now, why did I divide? Remember, it is total variable cost is equal to number of students times variable cost per unit. And this is what we are looking for. So using the low side, we have this guy and we had this guy. What we didn't have was this guy. So what we did was, we made one the subject of the formula. We made variable cost the subject of the formula. So this one will be divided by this one. That's how we got our variable cost per unit. Good. So now that we've gotten our variable cost per unit, we can now obtain the total variable cost for the high side. That's the 40,000 naira. And that will be what? CVC for the high side. Let me put H here to represent high side. That's this H representing the high side. That would be number of students, 40,000 times 1.5, and we'll be having our answer to be 60,000. So our TMC therefore would be, of course, 141,000 thousand minus into brackets 60,000 plus 50,000, which will be giving us 31,000. So that's first question solved. First question solved. We are told to bring out the maintenance cost or the mixed cost from the total overhead cost of the high side, where the level of output there, the student population is 40,000. This is the formula. We inputted our total overhead. We are looking for our total mixed cost. We represented it with the famous unknown X. And then our fixed cost is 50,000 naira. Where did we get the 50,000 naira from? From the information of the breakdown of the total overhead cost of the low side. All right, because it's a fixed cost, so for both the low and the high, it is the same. So 50,000 naira. What we did not have was the total variable cost. Why didn't we have that? Because we did not have the variable cost per unit and the total variable cost, as it were. All right, so we had to obtain the variable cost per unit from the information of the low side. We got our variable cost per unit, which is the same thing. The only thing that was changing, as it were, the only variable there was the level of output, which was the 40,000 naira. We got it, we slotted this back here. Total variable cost equal to 1.5 times, number of students 40,000 times 1.5 variable cost per unit, which was what we did here. The H representing the high side, so you do not mistake this for this. Then we slot it back in, and we got our TMC using the usual substitution, using the usual, disposition. All right. So second question: determine the fixed cost element in the maintenance cost. Imagine the maintenance cost. I will just solve. All right. So, but let's write out some interesting details. Remember, we have the high side. It will help us faster. We have the low side. And our level of output, which is the student population. This is 40,000, 30,000 students. Our total overhead is 141,000 and 122,000. And now our maintenance cost or our mixed cost for the high side, as we calculated, was 31,000, and then for the low side 27,000, if I am not mistaken. And no, I am not. So now they asked us to determine the fixed cost element in the maintenance cost. Now you'll be asking, all right, the mixed cost element you said is a combination of variable cost, the fixed cost, and the maintenance cost. All right, in the mixed cost element. So which side are we going to be using, the high side or the low side? Now that's where the procedure comes in play. Now the procedure in high-low method requires that first thing first, we will look for the difference between the level of output, the high level of output and the low level of output. So step one, level of output difference. Which will be equal to what? 40,000 minus 30,000 is equal to what? 10,000. That's the difference. Step two, not necessarily step two, because the first one is to identify the highest and the lowest step. The second step is to find the difference between the highest and the lowest. Then the third step, because I'm joining them together, the third step is to identify the corresponding costs of the high side and the low side. Corresponding cost of the high side and the low side. And now, since we are talking about the fixed cost in the the fixed cost element in the mixed cost, we'll be working with, because I said corresponding cost in the high side and the low side, so we're working with the mixed cost element in the high side and the low side. And then the next step as well will be to find the difference. That's step 4, but for the sake of mathematics, this is step 2. So level of output output cost. Let me underline the cost so that you know there's a difference here. which will give us 31,000 minus 27,000, which will give us 4,000. All right. Now the next step in the order of things, which is literally step 5, would be that for us to obtain our variable cost, we'll need to divide this level of output cost by the level of output. So step 3, because of what we are solving, that will be variable cost will be equal to 4,000 divided by 10,000, which will be giving us 0.4. All right. Now, step 6 in the procedure would be, yes, to obtain your fixed cost, you minus it from your variable cost. All right. Good. So, there has to be a formula. What is the formula? Which is going to be the mixed cost, of course, is equal to the total variable cost plus fixed cost. Or so that we won't confuse things, let's just use variable cost. Variable cost times fixed cost, and it's fixed cost we are looking for. Therefore, fixed cost is going to be mixed cost minus variable cost. Now you may ask, which side are we using, the high side or the low side? You can use any of the sides, you will get the same answer. Remember, fixed cost. So let's do our thing. So let's work with the high side. High activity. Let me call it high activity. Let me be professional. So fixed cost will be the mixed cost of the high side or higher activity is 31,000 minus our variable cost 0.4 times the student population of the high side 40,000. Remember we did something like that initially. So this is going to be giving us 0.4 times 40,000, 16,000. So this is 31,000 minus 16,000, which is going to be giving us 15,000. So if you do this for the low activity, you will get the same answer. All you just have to do is substitute this one with 27,000, substitute this one with 30,000, and you will have the same answer because it's fixed cost. All right. So without further ado, let us go to question C. Question C said we should express the mixed cost as y is equal to a plus bx plus c. Please, let's pay very close attention. Sorry, y equal to a plus bx. Please, let's pay very close attention to the demand. The demand here is what? The mixed cost, not the total overhead cost. So they say we should express, normally mixed cost is equal to fixed cost plus variable cost. All right. So they say we should express it as this. So our fixed cost we got was what? 15,000 naira plus our 0.4 that is somewhat fixed. You understand? It's the variable cost per unit. It is somewhat fixed for both the high side or the low side multiplied by the level of activity. That will be 0.4 times your x and then your y. What is the y representing? Y is representing, of course, the mixed cost. What is x representing? X is representing your level of output. All right. So let's move to the last one. The last one says we should now find the total overhead. That's the big man of the big men. The total overhead cost for 20,000 students. So what they are telling us here is that the level of activity is what? Yes, it's 20,000 students. So total overhead costs, let me write it as total overhead, which we know to be total variable costs plus total fixed costs, plus total maintenance or mixed costs. Stay with me. Stay with me. Stay with me. Now, we are working with 20,000 students at 20,000 students. That's our level of activity, yeah? So, stay with me. Let's break this down one by one because of our board. Total variable cost. Total variable cost. Remember, from the calculation we did at this point, we got this variable cost per unit to be 1.5. So that will be 1.5 times the level of output or level of activity, 20,000. Variable cost always has this symbol with it. Sorry, I pressed plus instead of multiplication. 30,000. Total fixed cost. Total fixed cost is going to be what? 50,000. It's going to be 50,000. Now, total maintenance cost is where we will now use this guy. So total maintenance cost, which is equal to what? 15,000, which is its own fixed cost, plus 0.4, which can be likened to this 1.5, then times, you get it, 20,000. So that's going to be 0.4 times 20k plus 15,000. All right, so that's 23. Yay! 1, 2, 3. So our total overhead would be 30,000 plus 50,000 plus 23,000. $103,000. And that is that for the high-low method. All right, so method 2. Remember, the first method was high-low method, or also called the range method, and the subject matter here is cost estimation, where the goal is to review or analyze, to look at historic data as regards cost with the aim to predict future costs, which in the end will help us make better decisions as managers. All right, so method 2, least square method. And I like this method because it's just formula, yeah? Just like literally just formula. And when we hear least square, of course, we tend to think of that guy. When I write the guy, you will see him. Okay, so the expression therein is y is equal to a plus bx, as we saw, yes, as we saw in range method, where this is our mixed cost, this is our fixed cost, this is our fixed cost per unit, and this is our what? Level of output. And so far, I have not seen this one being related to things like total overhead costs. I don't know if there are still questions like that where we have to use mean square to work with total overhead costs in particular. I do not know. I have not just seen so far, or I have not searched so far. All right. So, how do we find A? That's a very good question, although you didn't ask. That's x minus x prime. This is the guy I was telling you about. Y minus y prime all over x minus x prime square. And of course, we are having a summation here. We're having a summation here, and we say a hello to linear regression. So this is our B. Sorry, this is our B. Our variable cost per unit. Our B. Our A is basically y minus bx. All right, our y and our x, that's our mixed cost and our level of output, will be integrated into the question, if I'm not wrong. Yes, to be integrated into the question. You will see it. So let's take an example of illustration 2. Example, and that example is illustration 3 from IPE handouts. Illustration 3. So we have a particular table, that's the question, and then we'll be representing our power cost. We'll be representing our power cost as our mixed cost. Power cost will be our mixed cost, which ultimately will be Y. And then our machine hour, which is like our level of output, will be, which is X. Let me write it here. Level of output X. All right. So when we obtain Y, we obtain X, we obtain our B, we will come and obtain our A, because our A basically needs all of these unknowns to be in place. So according to the question that we were given, that's why I said this one is very, very straightforward. All right. So you have the question there displayed to you on the screen. So I'll just be going in straight for the Q. So first thing first, we divided through by 1000. We divide through by 1000. Why did we divide through by 1000? Easy. So that, you know, the answers, what we'll be working with, our data input will be small. All right, and we'll be able to navigate well, and also to avoid error. Imagine working with 80,000, 50,000, 5,000, and all that lot. So of course, we'll have our X come first. Don't have your X come first, please. Then we'll have our Y. Then we'll have our X minus X prime. Although I do not like as I'm calling it X prime as it were, but just for that level of difference. Then we have our Y minus Y prime, which is the same thing as this. Then what else? We'll have our X minus X square, and then Y minus Y prime. No, Y minus Y prime, X minus X prime. However, whichever you want to put first. Okay, so let me write out our parameters having divided by 1000. Having divided by 1000, we're having 8, we're having 9, we're having 6, we're having 7.4, we're having 8.6, 7.4, 8.6, we're having 9.2, we're having 3.7, we're having 7.8. Okay. Then this, we are having 3.6, 3.9. Remember, these are already in the question. 3.38, 3.87, 4.02, 2.095, 3.53. All right, these are already in the questions here. So our X prime, allow me to clean the top. Oh my God. All right. So let's find the summation of this. Summation of X will be giving us 8 plus 9 plus 6 plus 7.4 plus 8.6 plus 9.2 plus 3.7 plus 7.8, 59.7 divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. Of course, mean 7.4625 divided, let me put n, which is 7.46. Let's leave it as that. We'll do the same thing for y. Summation y over n, and then the rest of the gist, you get it. Plus 3.9 plus 3.09 plus 3.38 plus 3.87 plus 4.02 plus 2.095 plus 3.53. This is 3.43. All right. So x minus x bar, we're having this minus this, write it out. 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 And you get the gist, all right? So let me just, to save our time. And abracadabra, we have this. All right, very straightforward, but let's go over it again. So, like I said, our power cost, our mixed cost, which will be representing as y, our machine hour, which is the level of output. Remember, in the last one, it was the students' population, representing as x. To make things more clear, as it were, let me use prime here. So that, because there's a lot of y's and x's here. So, uh, so first thing first, we said we are dividing through by 1000, because in the question, that's what they did also. It's big. It's ambiguous, all right? So we had to shrink it down. So we had the x, level of output first, normal statistics. We have the y. Then we had our parameters. Don't forget our variable cost per unit. Don't forget so soon. X minus x prime, y minus y prime, over x minus x prime all square, summation. Then our a is equal to y minus bx. All right, I can as well use prime here, because this is what we'll be working with. Then I can say, I think that's all I can say actually. Yeah, that's all I can say actually. Okay, then y is equal to a plus bx. I can as well still use prime just for the sake of this class, so that we'll not be mistaking the x and all that. Okay, so we said this is representing our mixed costs, this is representing our fixed cost, this is representing our fixed cost per unit, this is representing our what? Yes, you are correct. Level of activity. Okay. Now we had our x. All right. 8 plus 9 plus 6 plus 1.4. Yes, plus this plus this plus this. We got summation x over n. What is the n representing? Remember our statistics. We are talking about the mean. Okay. So that's all over the number. That's 1, 2, 3, 4, 5, 6, 7, 8. All right. So when you sum all of this, you'll be getting 59.7 divided by 8. You'll be having your 7.46. Same thing too for y. You do it divided by 8, you'll be getting your 3.43. So you see that. What we've gotten our level of activity. That's why I said I like this method, because it's very straightforward. Our y prime, we've gotten it to be what? 7.46. Our x prime, we've gotten it to be what? 3.43. All right. That's why it's good to cross check. This is x, then this is y. Okay. A is equal to y minus bx. What is going on? Yes, y minus bx. All right. So we're on track. So we've gotten our x, we've gotten our x prime, we've gotten our y prime. Yes, I just want to make sure that we're on track. Then what are we looking for? We need to obtain our b, which is this formula here. How did we get it? Now for our x minus x prime, of course, this minus 7.46 will give you this, then the corresponding one like that, so plus n and all that, like that, minus this will give you the next one. That's how you do for this. Then for y also, same thing, 3.6 minus 3.46, you get this, 3.9 minus this, you get this, and that's how you keep doing for each and every one of them. Now after you've done that, as the label indicates, 0.54 square, you obtain this answer. 1.54, you obtain this answer. Minus 1.46, you obtain this answer. You obtain this answer. you obtain this answer, and so on and so forth. And then you sum them. You are not going to be dividing them by 8 this time because it's just pure summation. You sum them. That's for this denominator. For the numerator, we are having the difference between x and the difference between y coming together. That's this times this, you have this here. 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 And you do what? You sum them again together. So let's look for our b. We are going to look for a, but let's first obtain our b. So b is equal to summation of this times this. That's what was added here. 7.9525 all over this guy, summation 23.37556. And that would be giving us, without further ado, that will be giving us 0.34. That will be giving us 0.34. So we've gotten our b, we know our x, we know our y. So let's obtain our a. Now a is suggestive of what? Y prime minus bx prime, which is going to be y prime is what? 3.43 minus b 0.34 into bracket 7.46. Let me work this out because they did not reduce down to 2 decimal places. So let me work this out. So a is equal to, they got 0.892. So 0.89. Let's stop at 0.89. But remember, we divided through by 1000. So this is going to be times 1000. And of course, that will be giving us what? That will be giving us 890. That will be giving us 890. 0.893. Let me add 3 here. 0.893 times 1000. Remember, we divided through by 1000, so that will be giving us 893. Please, there's a naira in front. We are talking of fixed cost. All right. So we've gotten our answer for the fixed cost. Now, the second question now says, remember, oh, I've cleaned it. But if you look at the question, you see that in our table, we stopped at week 9. We stopped at week what? We stopped at week 9. All right. So they are now asking that what will be the total cost at week 9 if the level of output is 72,000 or be 7,200. 7,200. What is question 2? Says total cost at week 9 with the machine hour, expected machine hour at 7,200. 7,200. So first, let's divide this guy by 1,000. All right. So if you divide, let's work with it like that, since this is just it's on a small scale. So remember that our y prime is equal to what? A plus bx prime. So what we're looking for this time is y prime. Our a fixed, which is 893. Plus, we are not working with this one. Since we've already multiplied this one by 1000, we're using this one here. Plus b 0.34. Excuse me. Then plus times 7,200. My answer may differ a bit because of my approximation, but the concept changes not. The concept is fixed. Plus 893. 3341. So we're having 3341. But in the handout, they got 3340.75. But here I got 3341. And that difference, as it were, is because of I use 2 decimal places, but in the handout they use 4. But the concept is a fixed concept. And ladies, gentlemen, and all the inhabitants of the world, this will be, for now, the end of this class. Thank you, and see you again. I give a shout out to the tutors that have been before me. I give a shout out to the back end of this work, which is that unique. I give a shout out to industrial and production engineering students that will be watching this. IPE501 is scary. No, it's not scary. IPE501 is not scary. We'll be having this exam this Monday. So, yeah, yeah. Thank you.